So ito yung kanina. Sabi natin from some sort of scratchworks computation for this example, limit of 1/3 x minus 2 as x approaches 3, limit is -1. For the proof, I already mentioned epsilon greater than 0, and then the choice for delta should be thrice of epsilon. Okay, we arrive at this after some computation. And then of course, upon continuing with the proof, where is that, this part, we really have shown that if the absolute value of x minus 3 is less than delta, which is 3 epsilon, we can really show that the absolute value of f of x minus L is really less than epsilon after some computation. Okay? But then of course, nasa yun? Yeah, this is the summary. Okay, but then before I continue, let me just show you how it actually works with the graph, because someone requested, and actually I meant to do that, but then initially I was planning to do it with the general example. Itong example natin ito kanina. But then since one of the participant requested, let's do it for this one. So I just simply prepped this slide a while ago with some markings again. So ito nakuha natin kanina to show that indeed using the epsilon delta definition that the limit of this as x approaches 3 is -1. For every epsilon greater than 0, we have to choose or set delta to be thrice epsilon. So maybe we can do a specific value. Let's say iset natin ang consider. What any specific? Anong gusto niyo yung value ng epsilon? Siyempre, pag yung piliin yung malalaking epsilon, choose small epsilon because we want these values of function values that are near this limit -1. So anong gusto nating value ng epsilon? Anyone? Any naman, pwede naman kahit ano. Sabihin natin small siguro. Okay na ba sa inyo ang 1/6? Okay. Okay. Specifically lang consider not greater than, consider epsilon to be equal to 1/6. So if epsilon is 1/6, medyo pala maliit, mahirap ipakita dito, but then just imagine 1/6 lang yung epsilon. So from -1, the maximum distance is just 1/6. This is just about 1/4. Okay lang for illustration Sorry dahil kasi medyo maliit yung graph natin. But then ang gusto kasi natin, ang epsilon daw natin is 1/6. So for this illustration, ang ibig sabihin niyan, ito, tita lang natin to. Yan, sobrang liit, 1/6 lang. Okay, sorry kung yung mga lines ay hindi nagmi-meet ng tamang 1/6. Again, it's due to some due to the illustration spacing of this illustration. So bakit ito rin gusto raw natin, sobrang liit. Okay, kung ang gusto raw nating epsilon is 1/6, according to our prior computations a while ago from the general case, we have to choose epsilon, delta to be thrice of epsilon, and thrice of epsilon is thrice of 1/6 is 1/2. Okay, so our delta should be 1/2. Okay. Okay, I hope you got that. Nakuha naman natin, na-follow. So, ibig sabihin ito palang delta natin dito dapat ay 1/2 lang so that mas magandang illustrate yung 1/2. Ang daming nasa windows ko. Hindi lang ayos ko lang yung window ko para medyo mas maliit. Okay. So, dapat ito pala ay 1/2 lang. So, dito lang natin ito. 1/2. Yan, 1/2. Pwede siguro ito sa 1/2. Okay. So again, hindi po exact yung aking mga distances dito, but let me just give you the idea. Sabi kasi nung ating proof kanina, for every epsilon greater than 0, I can choose 3 epsilon to be my delta. Specifically, if epsilon is 1/6, I can choose delta to be 1/2. So ito. Okay. Medyo malaki pa nga but then again, yan, ulit-ulitan pa natin. Sorry, hindi ko na mapaliit yung mga parentheses. But if you want, you can make it smaller. Okay? So probably can do better. Okay. Actually, so ganito sa board, kaya nga lang tayo ay online ngayon. Okay. Yeah. Okay. So yun nangyari. Ano yung sabi natin? For every epsilon, in this case, epsilon is 1/6, there should be a corresponding delta, in this case, 3 epsilon, such that if x is within here, so just simply put an x here, choose an x here, and then the corresponding function value should be around here. So talagang naman ang mangyayari for this one. If you choose an x here, you put it there, kung ano yung kanyang corresponding point sa graph, and the corresponding y value will also be around here. Okay? So yun yung gusto nating sabihin. For every epsilon, in this case specifically 1/6, although in my illustration parang 1/5 lamang siya, sorry for that, but then you can make it smaller if you want. Kung gusto nyo 1/6 talaga, mas maliit pa dapat. Okay, yan, parang ganyan. Okay? Yan. Yan. Mas 1/6 na siya ngayon. Yan. So for every epsilon, in this case 1/6, there should be a delta, in this case 1/2, such that if x is within this 1/2 distance from 3, then the corresponding function values will be around here. Okay, yung gusto nating sabihin dito. And then remember, I mentioned to you that the choice of delta is not unique. Like kasi sabi na kasi natin dito, if we choose delta to be equal to 1/2, sure na tayo na lahat ng excess dito, ang function values will be here. But then do notice, pag mas niliitan natin yung delta, yan, let's say mas maliit na delta, less than 1/2, it will also work. Kasi ang gusto kong delta ay 1/10. Oh, okay din lamang. For epsilon equal to 1/6, ang piliin kong delta ay 1/10. That is still okay because if I choose an x that is very inside that one, sure pa rin tayo na narito siya sa within 1/6 distance from L. Okay? Yun yung nangyayari yun yung nangyayari. But then again, sabi nga natin, enough na may isang delta. That's why ang sinuggest natin kanina for the general case, simply choose 1/2. But if you're going to choose a delta less than 1/2, that is still okay. Yun. Mas maliit. Dahil kasi ang gusto lang naman nating sabihin, we can find an interval of x values around 3 such that the corresponding function values will be of epsilon distance from -1. Again, ano yung goal ni delta? We want an interval of x values around 3 such that the corresponding function values will be around -1. So natin sinasabi na iisa lamang yung choice ng delta, there can be more. And in case you are wondering bakit talagang naging limit yung process natin, like example nyo kasing gawin, you choose a very small epsilon. Ang laki pa nga nung 1/6, gusto nyo 1/100. Kaya nga lang, in terms of graph, that is quite complicated to do. So just imagine, sobrang lapit na raw talaga nung ating yun. Yeah. Sobrang liit na nung distance natin, 1/10. Hindi ko na siya ma-drawing dito. I hope you can follow me kung bakit mahirap na siya ipakita dito. Look at my choice of epsilon, 1/100. And sabi sa atin, for the purpose of easier computation, hindi ko na lang 300. Okay? Para lang mas madali. Okay, 1/300. Mas maliit siya. So sabi natin, ang corresponding daw delta natin dapat ay 3 times 300 ay maging 1/100. And do notice, hindi yung mangyayari, liliit din itong delta na corresponding na to. Sobrang lapit din lang niya doon. Okay, so, and then still we are sure that if the x's are within here, then the function values will be of epsilon distance, and you can really make it smaller and smaller. Huwag niyo syempre gawing ito, no? But then again, mahanap pa rin yung corresponding delta, whatever is that corresponding delta. And still, if the x's is within delta distance, the corresponding function values will be less than epsilon. So ang goal talaga natin dito is just to show that for every epsilon, we can generalize a choice for a delta. However, you can be more specific and you can really see here that if you choose smaller and smaller values of epsilon, there will be a corresponding values for the delta, and still we can guarantee that requirement. So makikita talaga yung concept ng approaches if you consider very arbitrarily sobrang small values ng epsilon. Okay? So kung gusto niyo mas maliit pa na to, but of course you don't have to show it for this one. I guess you already get the idea. Okay? That's the idea behind the epsilon delta definition. It talks of the distances. Kapag binabound nyo raw yung mga values ng mga gusto nating function values by epsilon, we can also bound the values of the x's such that if the x is within here, then the function values will be around here somewhere. Okay? And you can make this smaller and smaller. That's why dun sa definition natin, nakalagay lagi doon, however small. Hindi natin goal yung large values of epsilon because if you're going to choose large values of epsilon, it will not give you the behavior as x approach, the actual behavior of the function kasi masyadong malaki yung choices ninyo. What is interesting are those values of epsilon that are very arbitrarily small. And we want to do that for every epsilon. So hindi natin sinasabi gaano kaliit, but then we are actually considering every possible epsilon greater than 0, whatever is that small value, no matter how small is that, kung ano man yung inyong perception of what is small, it is captured by this epsilon greater than 0. Hindi tayo sinasabi that it should be 1/2, it should be 1/4. No. For every possible epsilon, no matter how small, smaller than what you think is already small, we can still accommodate that. There will still be a corresponding delta. Okay? So maybe kung gusto niyo pa, i-zoom in niyo pa yung graph if you want, and then you make it smaller and smaller, and no problem because we already showed that in the general case, we can always do that. We can always find a corresponding delta. Okay? So yun yung nangyari dun sa ating approaches. Rather than looking at the graph and tracing the graph for approaches, you are putting bounds on the possible values of the function values and the corresponding values of the x's. Yan. So pag if you are good in animation, and I think some of you can do this even in paano siyang gawin kahit sa ano nga 'yon? Kanya siyang gawin kahit sa GeoGebra. You can animate this in GeoGebra that really, if you're going to move the epsilon values, you are going to get a corresponding the values of delta. But then I'm not really good in animating in GeoGebra, but then to those who are skilled enough in doing that, you can do that. That really moving here will result to movements here such that the epsilon delta is satisfied. Okay, so I hope that gives you more ideas on how the epsilon delta will work. Okay.